Hi folks, welcome back to Moonshine Radio here. Today let's talk about the FM Quadrature Detector. Kind of an old school way to demodulate FM signals. And today we'll cover this on Moonshine Radio. Alright, so the basic idea of a quadrature detector is you got your FM signal there. And what you do is you split the signal. And one side goes to a mixer or a multiplier. And the other side, we're going to shift it by 90 degrees at the carrier frequency of the FM signal. And that will go through a multiplier there, or mixer in reality. After that, we'll run it through a low-pass filter, and bazam gazam, you'll have the audio of whatever was in the FM signal. Now, the idea is that we have to make a 90-degree phase shift at the frequency center of the carrier. And as the FM signal deviates off the carrier, it has to linearly add an additional phase increment. And the idea being is so that we can use it as like a phase detector. So this plot here kind of shows what we want. At the frequency carrier, we want to have 90 degrees, but as we deviate plus or minus off the carrier in relation to the FM deviation, we wanted to give an additional phase shift. And that's kind of the idea of the quadrature detector. And basically the idea is we're using this as a phase detector, in that if we have two signals of the same frequency, but different phase, if we feed them into a mixer and then low pass filter, what we'll get is a DC signal that is proportional to the phase difference of those two signals. So that's your classical definition there of what a phase detector is. So that's why we're having it go through that little 90-degree network so that we get a phase difference now as the carrier moves around, and then we can easily recover the audio or the FM signal. Now, in the old days, in the 90s, 80s, 70s, this is what you had to do. You had to make some LC tuning network here, and you had to tune it exactly at the carrier. This was commonly used in TV sets, police scanners, really any type of narrowband FM radio. May have been used for wideband FM as well, but for the most part it was definitely used for narrowband FM radio. Stuff of frequency deviations of 25 kilohertz or less, say. So if you had those old police scanners or a TV set, which almost everyone did, this circuit here was how it was getting the FM signal to audio. It was using what's called a FM quadrature detector. And this required tuning. You had to have a scope and some non-metallic screwdriver there, and turn the slug and the inductor until you got the max voltage, blah, blah, blah. And half the bobbies did it wrong because they were drunk and didn't know what they were doing. So, over the years, this kind of lost favor because it required kind of manual tuning, and as people just got dumber, they didn't know what they were doing. Anyway, to implement this in the DSP realm here is actually very, very trivial. If your FM signal is centered at fs over 4, this picture here shows how you do that. You just take your digital signal, delay it by one sample, which is extremely easy to do in DSP, multiply the two signals together, low pass filter it, and bing bang boom, you have the audio of what was in that FM signal. And the reason why the FM signal has to be centered at fs over 4, we'll show you that here. First, we'll show you that if you have a signal X and you shift it in time by some value, t0, the Fourier transform tells us you will have a linear phase shift, shown up there, e to the negative j 2 pi f times t0. Well, if we make t0 equal 1 sample, or it's ts, the sample period, which is also equal to 1 over fs, and if we make our FM signal be centered at fs over 4, We plug those numbers in the equation there, and we see that we get an exact 90-degree phase shift at the Fs over 4 point. And as the signal deviates off of that, it gets an additional phase shift, which is exactly what we want. So that's a Fourier transform property that some of you may have learned in EE 20 years ago and didn't know what it was ever going to be used for. Well, here's a valid application. I will also say, if you have a scenario totally unrelated, but if you have multiple DACs and one of the DACs gets off or delayed by a sample, what you will see in phase will be an exact linear phase that follows this equation here. E to the negative j 2 pi f times t0 being the time delay. See, all that stuff you learned in school does have an application. It's just that you had horrible teachers that didn't know anything on how to apply it. Anyway, below this video is a link to an audio wave file sampled at 48 kilohertz that is an FM signal centered at Fs over 4 or 12 kilohertz, and the audio contains an Amazon claim code. So basically, you got it. The first person that demodulates that FM signal gets themselves a Amazon claim code so that they can go buy some crap on Amazon. Well, I hope you've enjoyed this simple talk today on an FM Quadrature Detector. There's plenty of videos I saw on YouTube about this, but I didn't like them. They were explained horribly and, well, didn't really explain anything at all. Anyway, I hope you learned something. If you have any questions about this, please leave them in the comments, and Dr. Moonshine will be more than happy to answer your questions. Live from Moonshine Radio University, this is Moonshine Radio.